Let's take a look at a special type of function, a function known as a piecewise function. A piecewise function is a function that is defined by multiple equations over an explicitly stated domain. For example, here we have the function f of x is equal to x, comma x is less than 2, f of x is equal to 3, comma x is equal to 2, and f of x is equal to negative 1/2 x plus 5, comma x is greater than 2. Notice that there are 3 different pieces to this piecewise function. You could have a piecewise function that has 2 pieces, 3 pieces, 4 pieces, it doesn't matter. In this particular case, there are 3 pieces, and each one has a corresponding domain associated with it. So, for values of x that are less than 2, we want to use the first piece of this equation, y equals x. For values of x that are equal to 2, I'm going to use the second piece of this equation. My output is 3. For x values that are greater than 2, we want to use this third piece of the equation to give us our function values or our graph. Okay? Note that the domain of each piece is explicitly stated. So, evaluate the following. F of negative 1. Well, this means that we need to plug in negative 1 for x. Well, where are we going to plug in negative 1? Well, let's take a look. Because negative 1 is less than 2, that means we want to use the first piece of our piecewise function. Notice that plugging in negative 1, well, that simply gives us negative 1. Evaluating f of 2. This means we need to substitute in 2 for x. Well, what does this tell us? When x is equal to 2, my output is equal to 3. This actually is going to correspond to a singular point. When x is 2, y is 3. F of 2, therefore, is equal to 3. And if I asked you to evaluate f of 4, well, what part of the domain does x equals 4 fall under? 4 is greater than 2. Therefore, we would plug it into the third piece of our piecewise function, giving us negative 1/2 times 4 plus 5. That would be negative 2 plus 5, which gives us a positive 3. What about f of negative 4? Well, again, what part of the domain does x equals negative 4 fall under? Negative 4 is less than 2. So we would plug that into the first part of our piecewise function, giving us negative 4. What about f of 6? Well, 6 is greater than 2. Because it falls under the domain stated for our third piece of the piecewise function, we would plug it into the third piece of information, giving us negative 1/2 times 6 plus 5. Negative 1/2 times 6, that gives us negative 3 plus 5, leaves us with 2. Notice, this is what the graph of the piecewise function would look like. Okay? For values of x that are less than 2, the graph looks like the line y equals x, right? We have a y-intercept at 0 and a slope of 1. When x equals 2, y is equal to 3. That's our second piece of the piecewise function. We have this singular point. And finally, we have y equals negative 1/2 x plus 5 when our x values are greater than 2. We're going to talk a lot more about graphing piecewise functions later on in the chapter. For now, you just need to know how to evaluate them. But make note that every single point on this piecewise function would correspond to the equations that define our function f of x. Okay, let's try another one. Here's another piecewise function. Notice that this piecewise function has 2 pieces to it. We have g of x is equal to 2x plus 1. That's the equation that we want to use when x is less than 1. And we have g of x is equal to 3x minus 6 when x is greater than or equal to 1. Okay? Note that the domain of each piece is explicitly stated. Find g of negative 2. Well, which domain does negative 2 fall under? That's going to be our first piece, right? Negative 2 is less than 1. Therefore, we are going to plug that into the first piece of the piecewise function. That's 2 times negative 2 plus 1, leaving us with negative 4 plus 1, which gives us negative 3. To evaluate g of 0, which part of the domain does 0 fall into? Well, 0 is still less than 1. Therefore, we are going to plug it into the first piece. That leaves us with 2 times 0 plus 1, giving us 1. Now, g of 1. G of 1, to evaluate g of 1, again, let's look at our domains. Here I have x is greater than or equal to 1. Because it falls under the second piece, the domain of the second piece, we are going to plug 1 into the second piece of the equation. That is 3 times 1 minus 6. 3 times 1 is 3, minus 6 leaves us with negative 3. And to evaluate g of 2, again, 2 falls under the domain of the second piece. 2 is greater than or equal to 1. Therefore, we plug it into the second piece of the piecewise function. 3 times 2 minus 6 leaves us with 0. And here we have the graph of what this piecewise function would look like. Notice for x values that are less than 1, our graph has a slope of 2x, with a y-intercept of 1. Notice for our x values that are greater than or equal to 1, the slope of the graph is 3. And if we were to continue this line downward, we would certainly have a y-intercept at negative 6, corresponding to y equals 3x minus 6. Take a look at the endpoints here. Notice that open circles on the endpoints are going to correspond to endpoints that are not included. Notice that for this first piece, the endpoint of x equals 1 is not included in that part of the domain. But for the second piece of our piecewise function, where x is greater than or equal to 1, we have a filled in circle.